All right, what is a probability distribution? Well, you've been shooting free throws all season for your team, and you have an 80% free throw percentage. So in other words, you've made 80% of your shots. You're in the state finals, and that should say want to know. And you want to know what your probability distribution is when you go to the line to shoot two free throws, or maybe your coach wants to know because he wants to know whether he should put you on the line. Okay? So in this case, it'd be easy to make a tree. So let's say we were standing at the free throw line. Okay, you have two choices on that first shot. You could either make it and get a point, or miss it and make 0 points. Okay, so if you make it, you had an 80% or a 0.8% chance of doing that. And you had a 0.2% chance of making 0 points. So that's for the first shot. Then the second shot is you can either make it or you can miss it. And again, you've got an 80% chance here and a 20% chance here. And then so that's if you made it the first time. So now we can calculate, so for those two shots, this is if you make and make, that would be 0.8 times 0.8, which is 0.64. Okay, this next one is make first, miss second, and so that would be 0.8 times 0.2, or 0.16. So you have a 16% chance of making the first one, missing the second one. And then if you miss the first one, then you've got two chances again. You could either make it or miss it. And so there would be 0.2 for missing the first shot, 0.8 for making it. And so you got a 0.16% chance. And then here is if you miss them both. So 0.2 and 0.2, okay, which is 0.04. So here's your probability distribution for two free throws if you have 80% chance of making your free throws, each one. And if you notice, when you add these together, like here, these two, that would be 0.32. You have a 32% chance of making at least 1 point, at least one of them. 64% chance of making them both, and a 4% chance of missing them both. And if you add those together, 0.64 probability distributions always have to add up to 1, or 100% of the chances. And then plus 0.04, that would be 64 plus 36, which would be 1. So we've got them all. So this is a probability distribution. You can use this then to get your expected value every time you shoot and things like that. But the one thing you want to watch out for is if you have you'll know when you have a mistake, and this is kind of neat to know, and something that will help you as you're doing these problems, because you will make mistakes. But let's say you had a probability distribution of like this one. Say, I don't know, your chances of getting a 2, maybe you're rolling some weird, or drawing cards or something, but your chances of getting a 2 are 0.5, your chances of getting a 3 are 0.3, and your chances of getting a 7 are 0.4. Well, this is not possible. You've got an error in this distribution. So in this case, this would be 0.5, 0.3, 0.4. You've got more than your total would be, let's see, 1.2. And so this probability distribution doesn't work. And so it's kind of nice, because you could have went back here, or even this problem, and let's say you maybe added instead of multiplied, and you got 0.16 here as well, and you add those all up, you don't get 1. So you've always got to be 1 or 100%, and your probabilities have to be between 0 and 1. So let's say you multiplied 0.8 and 0.8 and screwed up on your calculator and got a 6.4. Okay, we got a problem there. It's got to be between 0 and 1. So those are two of the main rules with probability distributions. Well, it drive me nuts to have that wrong. But anyway, that gives you an example, and I hope it helps. And good luck, and see you next time.